Hi everyone, today we're starting with Module 2, Exponents in Scientific Notation, and to start off we're looking at Lesson 2.1. The title for 2.1 is called Integer Exponents, but we're only looking at the first half of that today, and so I'm titling that Finding Values of Powers. And our goal for this first half of 2.1 is to find the numerical value of any power. Now before we get into looking at examples or exploring this topic more, we first have to go over some terminology relating to powers. So typically when we think of a power, we might think of something like this. Okay? Now, even though I only wrote down two things there, there's actually three terms that we have to know from this. First of all, this number down here, that's called the base. And the base is the value being multiplied by itself. Okay? So our first term is the base, and that's the value being multiplied by itself. Next term is for this part up here. Let me circle that in red instead. That's called the exponent. And the exponent tells us how many times the base is being multiplied by itself. So it tells number of times to multiply the base by itself. All right, and then finally, this whole thing all together, that's called the power. Okay? So I don't really have a definition for power, it's just the base and the exponent put together. So again, the base is the value being multiplied by itself, and the exponent tells us how many times we actually need to multiply that base by itself. So now, I put together a table for you guys that I want to look through. Based on several different powers. The top row, we have 5 as the base. The middle row in red, we have 4 as the base. And the bottom row in purple, we have 3 as the base. So on the left column, all the way on the left, our exponents are all 4s. Next to that, our exponents are all 3s. Then in the third row, or third column, we have 2 as our exponent. In the very middle, we have 1 as our exponent, then we have 0 as our exponent, -1 as our exponent, and -2 as our exponent. So what I want you guys to do, I want you to take a moment and pause the video, and I want you to see if you can identify a pattern based on the values of these powers. So in the top row, 5 to the 4th equals 625, 5 cubed equals 125, 5 squared equals 25, 5 to the 1st equals 5. See if you can figure out what the pattern is there to determine what the values are going to be for the next 3 powers that we have there. So 5 to the 0, 5 to the -1, and 5 to the -2. All right, go ahead and pause and see if you can identify what the pattern is. All right, hopefully you pause your video and try to take a look at figuring what the pattern is for the blue values. Now I want you to go ahead and pause for a moment and see if you can figure out the pattern in the red values. All right, hopefully you pause for a little bit. Now finally, I want you to pause the video again to see if you can identify what the pattern is for the purple values at the bottom. All right, well, let's go ahead and talk through these. When we look at the blue values, hopefully what we see is that to get from each number, so to get from 625 to 125, and you don't have to draw that arrow there, to get from 625 to 125, you divide by 5. I don't like how this scrolls when I undo. Then, to get from 125 to 25, again, we're dividing by 5 again. To get from 25 to 5, we divide by 5 again. So now, if we're going to get from 5 to this value, same thing holds true. We're still going to divide by 5. So when we take 5 divided by 5, we do not get 0. When we take 5 and divide it by 5, we get a value of 1. So 5 to the 0 power is going to equal 1. All right? Well, we're going to keep flowing with that pattern. 1 divided by 5 is going to give us 1/5. And then if we keep going one more, 5 to the negative second, we're going to divide by 5 again. That gives us 1 over 25. All right? Now, if we look at the middle row in red, 4 to the 4th equals 256. To get from 256 to 64, again, we're going to divide by 4. So to get from here to here, we divide by 4. Same thing here, divide by 4, divide by 4 again. So now, if we're going to go from 4 to our value for 4 to the 0 power, we're going to divide by 4 again. 4 divided by 4 gives us 1. And if we keep going with that pattern, 1 divided by 4 gives us 1/4. And 1/4 divided by 4 gives us 1 over 16. All right, and finally for the bottom row, we have 3rd to the 4th equals 81. Dividing by 3 is our pattern now. So 81 divided by 3 will get us to 27. 27 divided by 3 will get us to 9. 9 divided by 3 will get us to 3. Still dividing by 3 each time. 3 divided by 3 gives us 1. 1 divided by 3 gives us 1/3. 1/3 divided by 3 gives us 1/9. Okay? So now that we've filled in those green values, I again want you to pause the video and see if you can identify any sort of connection between our positive exponents and our negative exponents. What do you see that's similar? What do you see that is different there? Go ahead and pause and take a look at it. So the pattern that I was hoping that you'd see here, if we see this 2, positive 2 here, and negative 2 here, we both end up with 25 as part of our answer. However, here, for 5 squared, it's hard for me to point with you guys being able to see what I'm pointing at. For 5 squared, that equals positive 25, or we have 25 in the numerator, because remember we could write this as 25 over 1. For 5 to the negative second, it's that fraction flipped. So 5 squared, we have 25 over 1. 5 to the negative second power, we have 1 over 25. So it's as if we take the numerator and denominator and we just flip those around. Same thing for 5 to the first. 5 to the first could be written as 5 over 1. 5 to the negative first is written as 1 over 5. So again, we're just taking that fraction and flipping it around. And the same thing we'll see that's true. We'll see that's true for 4 squared and 4 to the negative second power, 4 to the first and 4 to the negative first power. And we'll see that true in the bottom row as well. 3 squared equals 9. 3 to the negative second power is 1 over 9. 3 to the first is 3. 3 to the negative first is 1 over 3. All right, so what I want us to do is go ahead and write a conjecture for this. So the conjecture we come up with are that negative exponents have the reciprocal value of their positive values. So reciprocal just means that you're taking a fraction and you're switching around the numerator and denominator. So when you take the reciprocal of a fraction, the numerator then goes to the denominator position, the denominator goes to the numerator position. The last thing I want to talk about is this column right here. Now for all of those values, it doesn't matter if it's 5 to the 0, 4 to the 0, 3 to the 0, it doesn't matter whatever our base is. If our exponent is 0, the value is going to equal 1. All right, so our next conjecture, When the exponent is 0, the power will equal 1. All right, so you're going to be having to do some multiplying, some thinking through some of these problems, but your homework is my HRW 2.1 homework, numbers 1 through 5. All right, so a short assignment. When you finish the assignment, you'll be able to work on taking the next video, and we'll do that in class tomorrow. Okay, so we're working on those 5 problems tomorrow in class, so don't feel like you need to go ahead and work ahead or anything like that. All right, any questions, make sure that you bring them to class tomorrow.